Active transport is a type of cell transport that requires the input of energy in the form of ATP. The proteins that conduct this form of transport are often called pumps because they force molecules or ions to move from an area of low concentration to an area of high concentration. This is commonly referred to as against the concentration gradient. One of the more common examples of active transport is the sodium-potassium pump. The job of the sodium-potassium pump is to move sodium ions, or Na+, out of the cell, and potassium ions, or K+, into the cell. Let's take a closer look at how this happens. The sodium-potassium pump has binding sites for 3 sodium and 2 potassium ions. Let's follow the movement of the sodium ions first. After 3 sodium ions are positioned within the carrier protein, an ATP molecule is split, releasing phosphate. This phosphate binds to a location on the exterior of the carrier protein, causing the protein to change shape. As the protein changes shape, the 3 sodium ions are released to the other side of the membrane. Next, 2 potassium ions position themselves within the carrier protein, causing it to undergo another change in shape. In the process, the phosphate molecule is released. Once the phosphate molecule is released, the carrier protein expels the potassium ions into the interior of the cell. The carrier then resumes its initial shape, completing the cycle. Notice that for every 3 sodium ions leaving the cell, 2 potassium ions enter. Since both sodium and potassium ions have a positive charge, this unequal movement causes an electrical gradient to develop across the plasma membrane of the cell. A number of cellular processes, including the generation of nerve impulses, use this electrical gradient.